Hello, welcome to section 2.4. What we're going to do in this section is solve and graph compound inequalities. So what that means is we're going to have more than one inequality in each of these, and we're going to be solving them going down the number lines. We'll have a couple problem situations, and then we're going to end up just solving some just compound inequalities basically and graphing our solutions on a number line. So in this first example, we're going to write a compound inequality in what's called compact form. So in this case, we're talking about, and I'll just kind of read through these, all numbers greater than or equal to 0 and less than or equal to 6. So let's think about what's going on here, and what's actually going to make this a little bit easier is if you can brainstorm a couple of examples for these. So think about some numbers that are greater than or equal to 0, but are also less than or equal to 6. So let's pick the number 3. 3 is greater than or equal to 0. That's true. And 3 is also less than or equal to 6. So what I'm going to do is write two inequalities first. I'm going to say x is going to be the number that's going to be greater than or equal to 0. So greater than or equal to 0. But I also want it to be less than or equal to 6. So it's going to look something like this for my two inequalities. So when I write this in compact form, what you want to do is put your variable in the middle. So if I put my variable in the middle, think about where 0 would be on a number line and where 6 would be on a number line. 0 would be to the left, 6 would be to the right. So if it's x is x is less than or equal to 6, what I'm going to do is bring that inequality over here. So this less than or equal to 6 shows right here. Here's where we kind of got a problem. This says x is greater than or equal to 0. Now I have 0 and then the x. So notice how the x and then there's the 0, and now it's the 0 and then the x. What that means we have to do is flip this inequality. So it's going to say, and this kind of looks goofy, 0 is less than or equal to x is less than or equal to 6. So now I want you to put a number in here again. Let's put 3 in for x real quick. 0 is less than or equal to 3. That's true. And 3 is less than or equal to 6, and that's true. So here's what it would look like if you wrote out your two separate inequalities, and here's what it would look like in compact form. And I'll do that here then. All numbers that are greater than 10 and less than 1,000. So like if I pick the number 500, that's greater than 10. It is less than 1,000. So x has to be greater than 10, and x also has to be less than 1,000. Notice with these, they don't have the little equal to's because we're not talking about something with the equal to. It's just greater than or just less than. So the way that I'm going to do this again, let's put our lower number first. We'll put our variable in the middle, and let's put our higher number over here. I know that on the right-hand side, x is less than 1,000. But over here, I wrote x is greater than 10. So if I flip-flop that, I could say 10 is less than x. So what I want to do is put a less than sign here. So notice that both of your signs are kind of pointing in the same direction. This means that 10 is less than some number, and that number would also be less than 1,000. So x is anywhere between and not including 10 and 1,000. Notice how this problem is different than the first one because we don't have those or equal to's. And then the last one here. So all numbers that are less than or equal to 87. So I want x to be less than or equal to 87 and greater than or equal to 83. So x is greater than or equal to 83. So let's write this from least to greatest. I would put the 83, and then I'd put the x in the middle, and then I would put my 87. And I know that x is less than or equal to 87. And then if I flip-flop this, because x is greater than or equal to 83, I would write it as 83 is less than or equal to x. So that one looks just like how we did the first problem. With these ones, I want to write the compound inequality. Now I'm just given the graph for each one of these. So what I'm going to do is write out, first of all, I'm going to write out both of the inequalities just to show you starting at both ends here what it would look like. So let's look at the first part, that x in this case, since this is a closed dot and we're going to the right, x would be greater than or equal to 2, and x is also, including 6, going to the left. So x is also less than or equal to 6. So I want to write that out in compact form. So write the 2, put the x in the middle, and then write the 6. And I'm going to bring over that x is less than or equal to 6. And then just like we did before, since this says x is greater than or equal to 2, that means 2 would have to be less than or equal to whatever x is. So again, pick a number. What's between 2 and 6? How about 4? So 4, notice it's on this double shaded part here. It's all the way in the middle. And it also works for both of our inequalities. I could have also picked a value of 6. 6 is greater than or equal to 2. That's true. And 6 is also less than or equal to 6. So since we had closed dots here, that means that 2 and 6 are actually both parts of our solution, which is different than the next problem. In the next problem, I know that x is greater than 7. It's not including 7. It's greater than 7. And x is also less than 25. So when I write this in compact form, I'm going to say 7 is less than x is less than 25. So this part in the middle would be your compact form answer. And then I get the last one. So with this one, we're going to have to count 1, 2, 3, 4. This one's at -5. And this is all the way over at, looks like 1 less than 10, so that would be 9. So the first thing I'm going to do is write my 2 inequalities first. I know that x is all the numbers that are greater than -5. Notice that it is not greater than or equal to, and again, this dot is not colored in like it was on these first ones. So x is greater than -5. I also have an open dot over here because x is less than 9. So when I write this in compact form, I'm going to write that -5, put the x in the middle, put the 9 over here, bring down this inequality. I know that x is less than 9, and then I would also just flip this one. So -5 is less than x is less than 9. For these ones, I'm giving you the inequality in both of these, and what we're going to do is graph them. So this is already in compact form. What we're going to do is look where these numbers are on the number line, and I also want to look at these symbols. This one says less than or equal to, this one's just a less than. So when it has that or equal to part, you want to shade in your dot. So let's look at where -6 would be on my number line. 1, 2, 3, 4, 5. -6 is right here. So I'm going to indicate that this is -6. I'm going to color in a dot. And then I'm going to go all the way over to where 19 is. And since that one's just a less than, it's not less than or equal to, I'm going to have to put an open dot. 11, 12, 13, 14, 15, 16, 17, 18, 19 is here. And what I'm going to do is connect my 2 dots in the middle then. Just drawing an arrow. So again, it's closed on one end and it's open on the other end. And that's because of the or equal to part. And I should probably be really picky about this and put the 19 down here too, just to indicate where the -6 and 19 are. I'll do that in this next example. -35 is less than or equal to x, which is less than or equal to 15. Notice on both of these I have the or equal to part, so that means these are both going to be shaded in dots. I'm going to look at where -35 is, which will be right here on a number line, and I'm going to put a colored in dot right above it. I'm going to go all the way over to where 50 is, and I'm also going to put a dot there, and then we're talking about all the values between those. So I'm going to go straight across. And then I'm going to make this so it actually looks like it's touching. Awesome. And again, that represents our solution to this. The x is any number that is greater than or equal to -35, and also it has to be less than or equal to 50. So on this last example, you'll notice we don't have the or equal to on one of these parts, so that's different. What that means is that we're going to have to put that open dot here because -5 is not part of our solution. So I'm going to go to where -5 is on my number line. I'm going to write where it is, and then I'm going to put a big open dot above it, and I'm going to go all the way over to where 45 is. Now notice, this is less than or equal to 45. So I'm going to go to where 45 is. I'm going to put a big dot here, put my 45, and then I'm going to connect my 2 dots, which indicates that x is really anything between these and including 45, but not including -5. So now we're going to write a compound inequality for a situation, each one of these. And we'll be really careful when we decide what signs we're going to use for the inequality. Kyle's car gets more than 31 miles per gallon on the highway, or 26 miles or less per gallon in the city. So I'm going to write this out. This is going to be two different inequalities. The first one here is I know that he is getting, and X will be the number of miles per gallon, he's getting more than 31 miles per gallon when he's on the highway, or he is getting 26 miles or less per gallon in the city. So X is less than or equal to 26 miles per the gallon in the city. And since it's 26 miles or less, that's why I have the less than or equal to here. So what I want to do is put X in the middle of this. I want to put 26 here, I want to put the X in the middle, and I want to put the 31 over here. So I know that X is greater than 31, but if I flip this going the other way, since this is X is less than or equal to 26, now if I write the 26 first before the X, I need to flip-flop that sign. So I needed to say greater than or equal to. So what that means, again, X is less than or equal to 26, or he's greater than 31 if he's on the highway. And that's one of those statistics you see a bunch of, especially when you're buying a new vehicle. So notice why one of these has the or equal to part and the other one doesn't. And it's all because this says more than, and this one says 26 or less. So this one's including 26 miles. The other one is not including 31. Next one, number of houses that will be built in a new neighborhood must be at least 14. So X is greater than or equal to 14, because 14 is okay. 15 is okay because it's at least 14, but no more than 28. So is 28 okay? It says no more than 28. So 28 is okay, but if I have 30, that's a problem. So X has to be less than or equal to 28 and greater than or equal to 14. So let's think of some possibilities. How about 20? How about 22? Those are good answers. If I have 12, well, that's not enough. 12 is less than or equal to 28, but 12 is not at least 14. So let's arrange this. I'm going to put 14 here, put the X in the middle, put the 28. X is less than or equal to 28, and it's also greater than or equal to 14, so if I flip-flop that. So what I want to do is kind of notice or draw a comparison between the first and second example. Let's compare and contrast here. With both of these, I'm able to write them in compact form. Here's your one main difference between the two of these. This top one is an or. What it means is it's either going one way or the other way. In this example, X was either less than or equal to 26, which means it would be pointing one way, or it was greater than 31, so it points like this. Whereas in this bottom problem, X could be anywhere from 14 all the way up to and including 28. So this would be an and. So if it's an or problem, you're going to have two arrows pointing outwards. If it's an and, it means that your solution is everything in the middle because it satisfies one inequality and the other inequality. You can't be both here. You can either satisfy one inequality or the other inequality. Can't do both. In this middle one, you can do both because it's an and. And then the bottom one here. At the high and low store, they sell high-end items for over $1,000, and then low-end items for less than $10. So it's kind of like if you combine a dollar store with a really upscale store, it'd be a really weird concept. But let's take a look at what that would look like with our two inequalities. So think about it. You're either selling your really high-end items or you're selling your really low-end items. So there's really not much in between. So that kind of indicates to me it's going to look like one of these examples where there's really not much in between here. You're either really low or you're really high. So they sell their high-end items over $1,000. So over 1,000 means greater than 1,000. If it would have said at least, then I'd be able to put the or equal to part, but it doesn't say that. It says over 1,000. The low-end items are less than $10, which means you're not going to find anything for $10. You'll find things that are less than $10. So let's write our compact inequality. I know that I'm going to put 10 here. I'll put X in the middle and 1,000 over here. so x is greater than 1,000. And I also know x is less than 10. So if I flip-flop that, 10 must be greater than x. So notice how the first example looks like the third example because the or. So because both of these have these greater than signs, it's going to indicate the or, and these ones have the less than signs, which indicates the and. So then just to finish these up before we start solving them, with these ones we are going to just basically graph this. So let's look at each one of these problems. What I'm going to do is break them up from compact form. So the first thing that I'm going to do here is break this up. If this says x is greater than, or I'm sorry, 8 is greater than x, that means I know that x is less than 8. And over here it says x is greater than or equal to negative 8. So this is a little bit different because notice how they're ordering this. They have their larger number on the left and the smaller number on the right. Traditionally, we wouldn't write it like that. You would want to write the lower number to the left-hand side, but you can do it both ways. So I'm still going to do this problem either way. I'm putting the negative 8 here, and I'll throw a positive 8 over here. And since I broke it up into two inequalities, I know that x is less than 8, so that means it's going to be going to the left. And this one says greater than or equal to, so that means I'm going to have to color in my dot, and since it's greater than or equal to, it's all my numbers to the right. Next one, x is less than or equal to 9, and it's also greater than or equal to 2. So what I'm going to do is put my 2 here on my number line. I'm going to put my 9 over here. I know that it's greater than or equal to 2, and I know that it's less than or equal to 9. So that means greater than or equal to 2 is going to go to the right. Less than or equal to 9 is going to have to be shaded to the left, and that's your solution. And then we have our last one. X is greater than negative 11, or x is less than or equal to negative 11. So this is a really weird problem. Reason being is we only have one number here. That one number is negative 11. So let's break this up. First of all, x is greater than negative 11 means it's going to be all the numbers greater than it, so open dot, shaded to the right because that would mean greater than, or it's all the numbers that are including 11 but shaded to the left because it says less than or equal to. So let's think about that. That really seems like it's strange. So like, would negative 15 work? Well, negative 15 is less than or equal to negative 11, so that works. What about 10? Well, 10 is greater than negative 11. So either one of those works. So when you really think about it, all real numbers are going to work here. So your solution is that really every real number is going to work as a solution. It's either going to be one or the other. If this would have said and, then it would be kind of weird, but we're not going to deal with one of those just yet. With these ones, we're going to be solving these and then graphing and describing the solution. So this will be the last few examples we work through. So with this one, solving the compound inequality, I'm going to do my reverse order of operations. Think about if you were to like cover up either side of this inequality, you would really just solve it for x using your inverse operations. So what I'm going to do is subtract 2, and I'm going to do it from both sides of these inequalities and from the middle of them. So 4 minus 2 is 2. Bring down the inequality. Bring down my 2x. Bring down the inequality. 12 minus 2 is 10. So that's my first step. And then my second step to get x by itself will be to divide everything by 2. So 2 divided by 2 means I have 1 is less than or equal to x, which is less than 10 divided by 2 is 5. So I have a compact inequality. Notice I'm going from 1 to 5. So I'm going to put a 1 here. I'm going to put a 5 over here. This one has the or equal to part. This one doesn't. So where it has the or equal to part, you're going to end up having to put a shaded dot, or the dot filled in. And where the 5 is, it's going to have to be an open dot because that one's not included. Now what I'm going to do is break apart this compact inequality. I know that since this says 1 is less than or equal to x, I could also write that as x is greater than or equal to 1. And it also says x is less than 5, and I'm going to write that down below it. So all the numbers greater than or equal to 1 and all the numbers that are less than 5. So your solution would be anything between those two. So x is greater than or equal to 1 and x is less than 5. So I'm really emphasizing the fact that this is an and compound inequality. Notice both of your arrows would be pointing inwards, so it gives you a giant solution in the middle of this. When we see an or, it's going to be pointed in the opposite direction. Next one, we do have an or. So these are two separate inequalities. I'm going to solve them separately. First one, I'm going to subtract 5 on both sides. So I get x is greater than 14 minus 5 is 9. Bring down where it says the word or. And then with this other one, I'm going to divide both sides by 3. So x is less than 3. So I want you to think about this solution. Well, first, actually, we'll plot these on the number line. I know that x is greater than 9. So that's an open dot. And it's going to be going to the right, all the numbers that are greater than 9. And then 3 would be somewhere over here. And this is going to be all the numbers that are less than 3. So notice it's an or inequality. They point outwards. But let's think about why. If I pick a solution for one of these, let's say 10. 10 would be somewhere over here. Well, 10 is greater than 9, so that works well. It's not less than 3, but that doesn't matter. It's really one or the other. So if I pick a number that's in the middle of these, let's say I pick the number 4. Well, 4 would be a number that's greater than 3, so that doesn't work. And 4 is also a number that's less than 9, so that doesn't work. So notice that is not part of my solution then. So you are either on one side or you're on the other end. And then the last example, it's another or. We're going to solve these separately, and this is going to introduce a separate thing where I have a negative coefficient here. So watch what happens when that time comes. I'm going to subtract 1 on both sides. Negative 5x is greater than or equal to 15. When I divide or multiply by a negative coefficient, so I'm going to divide both sides here by negative 5. When you divide by a negative, you have to flip the inequality. So 15 divided by negative 5 is negative 3. I'm going to bring down that word or, and then I'm going to solve this inequality on the right by adding 6. So I would get x is less than or equal to negative 8 plus 6 is negative 2. So in this case, x is either less than or equal to negative 3, or x is less than or equal to negative 2. So this is going to be kind of a weird one, where they're going to be pointed in the same direction. So x is less than or equal to negative 3. Negative 3 is here. So that's going to be all the numbers shaded in here to the left. Or it's going to be x is less than or equal to negative 2. So that's going to be all the numbers up here also going to the left. So really, anything that is less than or equal to negative 2 is going to be a solution to this problem. And the reason I know that is because there's some overlap here. If I pick negative 5, it satisfies both of these. If I pick negative 3, it satisfies one of them. If I pick negative 1, it doesn't work. If I pick negative 2.5, that'd be right here, and that would work. So anything that is less than or equal to negative 2 is a solution to this entire inequality. And that is all. So recap, this was a really long video. We solved inequalities, we graphed them, we went through a couple story problems where we had to write the compound inequality, we went off of a number line to write things in compact form, and then we also solved.